Hi, it's Mr. Baumgarten, and today we're building the classic Flappy Bird, which hopefully I can program better than I can play. Hey, I got through one. There we go. Two of them. Alright, let's just crash it and end the game and see how we can build this thing in JavaScript. To build this, we are going to be using a JavaScript library called p5.js, and as you can see here, it is a JavaScript library for creative coding with a focus on making coding accessible for artists, designers, educators, beginners, and anyone else. And effectively what this is going to do is build some functionality around the HTML object known as the canvas. So we could program this in raw pure JavaScript using the canvas functions, but it'll make it slightly more tedious than need to be, and p5.js just provides some extra functionality that'll make things a little easier for us, but it is still pure JavaScript that we will be using, and I'll explain the little differences along the way. So what I've got to get us started is from my website that I will have linked to this below, is a Flappy Bird JavaScript assets zip file. So if you extract that, the contents of that zip file will give you what we need to get started. And so you can see here I have given you the p5.js library and their sound file library that comes separately. I've got an empty, almost empty HTML and CSS file that I will quickly show you what's inside them. And I've got the media, and so this is just some PNG files that we will use for the background, the base. We've got our little Flappy Bird animated GIF, and we've got the pipes that we need for the game, along with the sound effects. So MP3 files for the different aspects of the game, and the font file that we will use for displaying things on screen. So I've got my empty folder that I've just unzipped all of this into, and I have opened that folder in VS Code. Alright, so I just went File, Open Folder, navigated to that folder which I've called Temp, and said Select Folder, and this is what I've ended up with. So if I take a look inside that HTML file first of all, it's a fairly empty, just boilerplate template kind of saying, okay, I'm creating an HTML document, and inside the header part of the document, this is just some saying, okay, I want this to automatically resize based upon the display properties of my device, which will help it work better on a mobile phone. The title is Flappy Bird, and I'm going to load in the CSS file that I'll show you, and then I just want to load p5.js library, the sound library, and then my main.js file, which is what we will write together. And then in the body of my HTML, if they happen to have JavaScript disabled, it's going to just say, sorry, this site requires JavaScript to function. And that's all that's happening inside the HTML. The CSS, all that's doing is removing the margin and the padding on the screen, so we don't have an ugly white edge to our page. And then here's all the raw p5.js stuff. Oops. Alright, so what we're going to be doing is we are going to create main.js, and in about 100 lines of code, hopefully less, we will make Flappy Bird. So main.js is the file that I want to create. And I will just quickly mention, actually, if you go to your extensions, make sure you have open with live server. So if I just go live server, okay, so yes, this is what you want to look for. So search your extensions for live server and install that, and then what that will do, if you go to your HTML file, you can right click on it and say open with live server, and that will open up your web browser and allow you to view the page that we are creating. So at the moment you can see there's nothing here, but it is running as if it was running on a web server for us. And this will automatically refresh as we make changes to it. So for instance, if I did happen to put into my HTML, what am I doing? Flappy Bird. All right, and then Alt tab across, you can see it says Flappy Bird. So I'll just get rid of that. Okay, let's get underway making Flappy Bird, shall we? Now, the way the p5.js library will work for us is there's going to be a few key functions that we will need, and it will automatically look for these functions, and if they exist, it will execute them for us. So we're going to make a function called preload. We're going to make a function called setup, and we're going to make a function called draw. And so the way that this works is somewhat intuitively, I hope. When p5.js starts up, it will look for the preload function and execute that. And the purpose of that function is to load up all of our media assets that we are going to want it to have. It will then look for a setup function and execute whatever we have in there. And then it will look for a draw function and just continually, repetitively run that as if it's inside a giant while forever loop, which effectively is what it would be behind the scenes. So the first thing we're going to want to do is to do our preloading and load all of our media assets. But we want to load them in preload, but then have them available in our setup and draw functions. So we need to create the variables that these are going to go into outside of the function. If we define a variable inside the function, it only exists for the lifetime of that function. So outside my function, up the very top, I'm just going to create a whole bunch of variables, and I'm going to use uppercase because these are constants. They're not going to be changing. Well, actually, I am going to tweak them a little later on, but near enough for constants. All right, so one for the background image, one for the base image, one for the bottom pipe, one for the top pipe, one for our bird animation, and then one for each of our sound effects. So we've got die, we've got hit, we've got wing, we've got a swoosh sound, and then we finally need one for our font. All right, and so these are just all of these different bits and pieces here. We're going to now load those in using our preload function. So the purpose of this function is to load all the media files. And so the let command will create these as just unassigned variables. So now inside preload, we're going to assign them. And so I'm going to say background, and we can see that VS Code is giving me a hint what I might be looking for. All right, and so now I can just use the load image function that p5.js is making available for us, and I'll put in here inside some quotes a string to where to find the various media objects. So this will be inside my media folder, and then /background .png, oops, and then semicolon on the end of it. So base is equal to load image media /base.png, and I'll just quickly dump the rest of them in. Right, so I've got my top pipe, I've got my bottom pipe. Then for your sound effects, instead of load image, we want load sound, and for your font, we want load font. So just make sure you use the correct function for each of those. All right, once you've got those done, all of these items will be loaded into our program, ready to go. The next thing we're going to want to do is get our setup function working, and we're going to need some I'm going to create another variable up the top here that keeps track of the size of the screen, because we want our game to automatically adapt based upon the resolution of whatever screen we are running it on. So I'm going to create a variable called game size, and I'm going to initialize this to 288, a width of 288 and a height of 512. That's just the resolution of my background PNG, so I'll use that as the default. But then if the screen is a different resolution, which it is going to be, we're going to change that. And in fact, so we're going to get the setup to do that straight away. Game size, let's just update that, and we're going to set that to window width with a capital W in the second bit, and window height. Right, and these are two variables that p5.js makes available for us to tell us the width and the height in pixels of whatever screen we of the window that we're using. And then we're going to want to get p5.js to create a canvas for us. So this is the HTML canvas equivalent that we are going to be playing our game on. And so we want this canvas to be the width and the height of our game size. So we're just going to use game size. So 0, the first parameter is the width, and then game size 1, the second parameter is the height. While we're here, so even though theoretically we want our background to be constant, we're going to cheat here a little bit. We want to resize our background to the dimensions of the window. So resize, background dot resize, and now we give it an x and a y coordinate, which or a width and a height coordinate, sorry. So that's just going to be game size 0 and game size 1, and that will resize the background. While we're resizing images, let's also resize that base picture to be the appropriate width as well, but we can keep the height what it was originally. So resize that to game size 0, but keep the height what it was. I'm happy enough with that, so that we can interrogate the base image to find out what its height was with base.height. Then the last thing we want to do in our setup is tell p5.js how many frames per second we want our program to run. So we'll set frame rate, capital R, to 25 frames per second. Now, just to kind of check that this is working, how about we draw our image to the background and see if that does it. All right, so to draw an image to the background, it's just going to be image, open the parentheses, oops, this is lowercase I, watch out if your VS Code automatically changes that, background, and I want to place it at the top left corner, the coordinates of which are 0, 0. So x coordinate 0, y coordinate 0 is the top left corner. So the x-axis starts at 0 on the left and it increases as you move right, and the y-axis of the HTML will start at 0 at the top and increase as you go down. So your y-axis is inverted to what you're used to with the math Cartesian plane, for instance. So if I take a look at what this may look like, there we go. I have my background image and it has fully resized. Oh, and I should point out what I'm doing here, how I've gotten it to do that. Let's okay, so if let's just close this all the way, shall we? If I go to my HTML, right click, open with live server, you will get something that looks like that. Okay, and I've resized it and it no longer fits, so let's just refresh and it will automatically adjust based the background to suit the size of the screen as we are wanting it to, which is fantastic. But you saw before I had it kind of looking like a mobile phone. We can get Chrome to help look like or test what it will look like on a mobile phone for us. And to do this, right click anywhere in your web browser and go down to inspect. and then you get this nice little menu across the top. Well, actually, if you don't, on this DevTools screen, so when I right-clicked and did inspect, this popped up. You can click this little toggle device toolbar, and that gives you a mobile phone screen where you can pick what phone you want it to be sized to. You can pick your orientation, and now if you refresh, right, it will emulate that phone, so you can see what your web page will look like on a phone screen. So I'm going to keep it in this mode for the rest of our video, because that is what I'm wanting to develop. I'm wanting this thing to work on a phone, so I'm going to keep that going, shall we? All right, let's get back to, hang on, all my screens have just gone funny on me. Okay, let's get back to our development. So keep your web page open so you can just tab flick between the two of them. Right, so the first thing I'm going to do is let's have a bit of an introduction screen that says welcome to Flappy Bird, and you know, click to start or something like that. Actually, I'm going to quickly also draw my base. So I want the x coordinate of the base to be on the left hand edge. The height of the base, right, I'm going to use the height of whatever my screen is, and then subtract the height of that image file so that it will always be at the bottom. So if I save and flick across, we'll see, okay, there's this base here now instead of it just being the green trees. Fantastic. Right, so let's use our text objects. So text, lowercase t, text line, and I'm going to align this to be center horizontally and center vertically, based upon whatever coordinates I give it. And I'm going to set the text size to 40 pixels, sounds good, and use a color of white. I don't know quite why VS Code default text suggestions are annoying me quite so much, but anyway, the text I'm going to write, okay, let's just have it say Flappy Bird, and where do I want to put this? I'm going to place this, so I'm using center, right? So I'm going to give it the center coordinate of the X so that it's nice and centered on my screen, and I might put it 1/3 of the way down the screen. So to do that, I'm just going to keep using this game size variable that I created. All right, so my width divided by 2 to give it the center location, and my height, game size 1, divided by 3 to give it 1/3 of the way. If I save and flick across, okay, I now have the text that says Flappy Bird. Let's also give it some text that says click to start, and that can also go in the center. Oops. But I'll put it at the bottom third of the screen. So times by 2 divided by 3 to make it 2/3 of the way down. Let's see what that, except that it's kind of hard to see there. I mean, I could change the color, but how about we just lower it down? Let's make it 5/6 the way down the screen. That'll do for now. All right, we can tweak it later on. All right, now once I click the mouse, I want to actually start the game. So I'm going to need a variable that tells if my game is running or not. So let's just come up here and say let game running, and we'll set that to false, lowercase on the F. And so I only want this to appear if my game is not running. I don't want click to start happening if it is. So let's come in here and say if open brackets, you need parentheses for all of your if statements in JavaScript. So this is change to if you're only used to writing in Python. The exclamation means not. So if not game running, so if not true, which means if it's false, which at the moment it is, what do we want it to do? I'm going to move this, so cut and then paste that into my if statement. So if it's false, if the game is not running, I want to display this nice screen. And inside here, if the mouse is pressed, right, and that's just mouse, capital I is, capital P pressed. This is a variable that p5.js makes available for us to detect a mouse press. So if the mouse is pressed, I'm just going to change game running to true. And that means that this screen will no longer, this code here to draw Flappy Bird click to start will no longer appear. It won't do anything else, right? The background is still there and the base is still there. That's been drawn 25 times a second, but without that piece of text now. So now that means if my game is running, let's give an else statement to this. So if game is not running, it's going to display all of that. And then down here, the else statement, intuitively this means, well, the game is running. Now we could just write all of our game logic in here, but let's separate it into a function just to make it a little easier to manage. So I'm going to make a function called play. And let's correct that up here. So function play. Open and close the curly braces to start and end the function. Yeah, again, this is a little different to Python. All right, contents of our functions between the opening and closing curly braces. So this play function will be responsible for processing our gameplay, and this will run 1/25th of a second. All right, so 25 times a second, this function is going to run when we are playing the game. So what are the different things that we need to take care of to be able to play a Flappy Bird game? So we need to sort out the pipes. We need to sort out the bird movement. So I'm just going to put in a few comments for the things, different bits and pieces we need to do. We need to detect collision. So has the bird crashed into the pipes? And we need to, let's print how many lives and scores. So how many points we've earned. And those are probably the key parts we need to sort out. So let's get some pipes scrolling across the screen first of all, shall we? So I'm going to create a couple more variables here just to help manage this for us. So if I scroll up to the top, I'm going to create a variable called pipe, and this is going to be the, if I come here, I'm going to give it the X location of where the pipe is. So with, again, placing these images, right, I need to give it the X and Y coordinate of where I want the top left of the image to go. So I'll just use this X value to keep track of the left edge of these pipe images. Now I'll use the Y coordinate maybe to mean like the top of the gap between the two pipes. Yeah, let's do that, shall we? So I'm going to start by making the pipe, let's start it at like 400 pixels across, and if our screen is greater than 400 pixels, it means we're going to be placing it off the edge. But that'll be nice to get us started. You know, when we first start the game, you don't want a pipe right there where the bird is and have it crash straight away before you get a chance to do anything. So let's start a little bit off the screen and give it time to scroll in, and then we'll just for the first time we run it, let's have the gap start at about 100 pixels down from the top of the page. But we can randomly choose this and change this next time, you know, as the pipes keep flowing through. So I've got that, and let's create a couple of other variables while we're at it. So we'll create a variable that keeps track of the gap between the pipes. So pipe gap, so that we can give this a default initial value of 100, and we'll create a variable for our pipe speed. So how many pixels do we want it to move to the left every frame, so every 25th of a second. So let's just make that 10 pixels per second. So if you want to make the game easier, you give this a smaller number. And if you want to make it harder, make it a bigger number. All right. So let's get the pipes up and running. So to just draw our pipe, well, we can't. Yeah, we can draw it. All right. So image top underscore pipe. All right. So the name of the image that variable that I've created, and we just need to give it the x and the y coordinate. So pipe 0 will be the x coordinate. The y coordinate for the top corner of the top pipe will be, if pipe 1 is keeping track of the y coordinate of where I want the gap to be, that's going to be the bottom of that top pipe. I hope that makes sense. So I'm going to subtract the height of top pipe to find out where that image actually needs to get drawn. And if I do the same, let's draw the bottom pipe. All right, that'll be the same x location because they are aligned on the at that x axis, and its top edge will be the starting point of the gap plus whatever the size of the gap is. So I might just come up here and quickly just make this like maybe 200, just so we can actually see it. And if I refresh, why are they not visible? Oh, because I haven't clicked it. There we go. Okay, so there's the pipes. And we can see we've got this nasty gap here that we might have to sort out and fix up with glitches later on. But yeah, so with 200 pixels in, 100 pixels down would be this point here. And then there's my gap. So that's what that is doing. All right, let's move it off the edge of the screen. Let's move it back. Let's make it like 500, so it's 120 off. Okay. Yeah. So let's get a scrolling movement happening for these pipes now. So before we draw the image, we want to scroll it to the left. So we'll take our pipe's x location and we will subtract from it whatever the speed is that we are wanting this thing to move. And if I save and run that, there's our pipe. All right, so now once it moves off the right-hand edge, we want it to circle back and come. Sorry, once it moves off the left edge, we want it to circle back and come back through the right. So to do that, if my pipe's left edge is less than, I don't want less than 0 because I want the whole pipe to pass by that left edge of the screen first. So it's going to be the width of the pipe has to have moved all the way. So it's going to be a negative number. All right, so from 0, subtract whatever the width of the pipe is. And we can use either pipe, so let's just use top pipe, get its width. All right, and we want that as a negative number, so if we stick that minus sign there. So if the x location that we're drawing our pipe is less than the negative of the width, we want to make our x location for the pipe equal to the width of our game, right? So that it's now on the right hand edge of the game. And so if I save and run that, once it scrolls past, it'll come back the other side. Perfect. We want to change the vertical location of the gap. So let's change pipe 1, the vertical location, and we'll make it a minimum of say 50 pixels down from the top of the screen, and a random number added to that of whatever the height of our game is, which is game size 1, but about 200 pixels up from that. And we can change the size of the gap while we're at it. So let's change gap to also being a random number. We say if we want a minimum of 100 pixel gap, and then we're going to add to that a random number between 0 and 100. So that it'll be a gap of between 100 to 200 pixels. So now if I come in here, our pipe should move and the gap should change every time it cycles through. Fantastic. That is our pipes kind of taken care of, other than the little glitch of the ends of them appearing. Let's make the bird move. So we've got our animated GIF. Let's make it appear on screen first of all. So the bird is going to appear at the location of, we're going to need a variable for bird location, which we haven't created yet, so let's come back up to the top here and create that. Let's give the bird a location, a starting location of 50 pixels in from the left edge and about 250 down. Sounds good to me. Oops. Okay, so let's we want this bird to be animated, and p5.js has a really cool thing built in where it will automatically make our animated GIF work for us. So that's nice for us. We've got this nice flapping motion happening for the bird. Let's get it to move when I click on the screen, because we want our bird to fly, and if we're not clicking on it to fly up, then it needs to start falling down. And we already saw there's this mouse is pressed variable that will get set for us, so we can check that every time we are running through our play function. So before I draw my image of the bird on the screen, I'm going to check, okay, is mouse is pressed. So if that is true, what do I want to do? I'm going to have a jump variable that keeps track of my vertical movements. So I'm going to say let's jump up 20 pixels. So I need to come up to the top here. Let's create this variable. Let jump equals, start off with at 0. So we're not doing any jumping yet. Alright, so 20 pixels of upward movement, and then after that if statement, I'm going to have if jump is bigger than minus 20. So negative 20 being I'm falling 20 pixels per frame, and so I'm going to make that be like my terminal velocity of falling. I won't make it fall at a speed greater than 20 pixels per frame. And so what I'm going to do here in this if statement is I'm just going to whatever is in jump, I'm going to subtract 2 off of it. Right, so the game starts at jump equals 0. Every time I hit the mouse, the mouse, it'll change to a positive number of 20. So it'll start jumping up 20 pixels in the first frame, and then what this will do is the next frame it'll move up 18 pixels, the next frame after that it'll move up 16 pixels, and so on. And so the amount that it moves up will gradually reduce, and then it'll start falling until it's falling at 20 pixels per frame. And so now all I need to do is change my bird's y coordinate by the amount that's inside this jump variable. So bird y coordinate, and then I am going to subtract off of it whatever is inside jump. So if I save and come back to here and click, okay, as I click the mouse, it starts moving up that 20 pixels, and you can see that it slowly then starts being subtracted down until it's falling at 20 pixels per frame. Like if I just let it go, it'll fall off the edge. Right, let's add the sound effects to it, because that is pretty cool as well, and fairly easy to do. We've created all these sound effects here. So every time I am starting a jump, I want the wing sound effect to happen. So it's just wing and then play, open close parentheses, and it's as easy as that. Now you might be able to hear that it's actually playing more than one wing sound at a time. Right, if I hold down the mouse, you can hear that. So I only want it to be playing one at a time, and this will also, what I'm about to do will also help me, will not let me just kind of hold the mouse down and infinitely move up. So what I'm going to do here is I'm going to change this. Instead of just saying if the mouse is pressed, I'm also going to make sure that the wing sound is not playing, because that's a nice convenient length of about half a second. It means I can then only trigger a jump roughly once every half a second or so, however long this sound effect goes for. So I'm going to say and, which in JavaScript is a double ampersand symbol, and then not wing dot is, and then capital P for playing, and that's a function, so that needs its own parentheses on the end of it. All right, so if the mouse is pressed and the wing sound effect is not playing, that's when I can jump by 20 pixels and start the wing sound effect playing. All right, so if I come in here, right, now if I hold down the mouse key, I can only jump about once every second or so. Right, so and it's judging that based upon if that sound effect is playing. So that's a nice little addition to that, I think, anyway. Right, so I have my pipes and I've got my bird. Now I need to detect if I am colliding. Now the way that p5.js doesn't have anything built in for this, so I'm going to write my own little function that's going to test to see if I am colliding with the pipes. So let's create this function, shall we? So I'm going to come up the top here and create a new function, and let's just call it isCollision. And what am I going to pass into this? I'm going to pass into this function my two images, and so that I can inspect them for their width and their heights, and I'm going to also pass in the X and Y locations of where they are, so that I can then kind of calculate if there's any overlap between either of those images. So let's just call this IM1 for image 1, and it's X coordinate and its Y coordinate, so X1, Y1, and then IM2 for the second image, X2 and Y2 for its X and Y coordinate. Open and close the curly braces. Now how am I going to test to see if I've got a collision happening? I've drawn a little diagram here, which hopefully I can get to appear on the screen. This took me a little while to work out, so I did this in advance. These are all the different, if we're just looking at the X values for now, because once we work out the rule for X, then the same rules would apply on the Y axis, and so we can just adapt them to match. So you can see here, if I've got an object that's kind of passing through another object, so the red versions of it are all the ones where there's a collision that I want to detect, and the yellow version is not colliding with this green object. And so I took a look at this and I was trying to see what are the rules in place. And this one here, this is not colliding along the X axis. I worked out, okay, the X coordinate, right, remember that's the left hand edge of our images. Right, so the green's X coordinate has to be greater than the X coordinate of the yellow box plus its width, because that will get me the right hand edge. And so provided that x and its width, so its right edge, if this is less than the left edge of the green, then I know that that is not colliding. Likewise down here, if the left hand edge, being x, is greater than this left hand edge plus its width, so to give me the right hand edge, right, then I know that that is not colliding either. If neither of those are true, then I've got a collision happening. So I want to test, does this apply or does this apply? And if either is true, then it's okay, I'm not colliding. And then I can do the same with the y, right? Because I could be overlapping, I can be colliding on the x, but I might not. But if the y is not colliding, then I'm still fine. So I've got 4 different conditions that I need to be checking, and if any of them is true, then I haven't got a collision. So let's figure out how to code that up. And so I've got an if statement, and I'm going to be checking those 4 different conditions. So I need the parentheses to contain everything inside the if statement, right? And then the or statement is a double pipe symbol. So different things that I'm wanting to check. 4 different things that I want to check. And if those are true, if any of them are true, then I don't have a collision, so I can return false. Right? And otherwise, I do have a collision, so let's return a true. All right, there is no collision. So what are these 4 things? Okay, so based upon that diagram that I had, all right, so if the x coordinate plus the width of the first image is less than the x coordinate of the second image, all right, so that is this scenario here. If the x plus its width is less than this x, then I don't have a collision. All right, and then the other one here, if x1 is greater than x2 and its width, then again I don't have a collision. So if x1 is greater than x2 and its width, then I don't have a collision. And then I can use the same logic for the y-axis as well. All right, so here x1 and width, so that's just y1 plus its height, if that is less than y2. All right, so I'm just doing a direct substitution, but for y's, and then if I turn this one into y's as well, all right, so that'll be y2 if that's greater than y1 plus image 2's height. That's my collision function, and we will have to test that it works as we expect. So let's do that. If, open brackets, is collision. So let's just write it up for the top pipe first of all. So I give it my image so that it can get the width and the height from it, and I need the x and the y location for the bird, so that's just bird 0 and bird 1. And then I give it my second image, so top pipe, and its x and y location, so its x location is pipe 0, and its y location, so the top of that pipe is 1 minus top pipe's height, all right, which is the same that I've got up here. All right, so let's test this. So if I give it some, let's just make it play the hit sound. So hit.play. If it collides with if the bird collides with the top pipe, that should play that sound effect for us. So let's come in here and There we go. And the bottom pipe. The bottom pipe is affecting it as well. Actually, everything's affecting it. What have I done? I've messed something up here. Okay, let's take a look. What have I got going on here? If we are colliding, how did I do this? Did I mess this up? Let's see, x1 image 1 width, x1 image 2, y1 less than y2, or there we go. That should be 2 and that should be 1. Right, that's x1 there, so its equivalent is y1 here, and then this is x2 and image 2's width, so y2 and image 2's height. There you go. Let's bug test our code. Alright, so the top pipe, alright, yep, and I can sail through the middle, and the bottom pipe, no collision. And I can go over the top pipe and sail underneath it. Okay. Alright, let's get it checking collision against the second pipe. So I'm going to use the double pipe symbol as an OR. So if I'm colliding against the top pipe or the bottom pipe. Now this is becoming quite a long line, so I'm going to just insert a line break here. But I'm going to copy, rather than typing all this out again, copy and paste. And just line that up. Alright, so let's change it. Instead of top pipe, this is the bottom pipe, and its location is, what did I use up the top here? That's pipe 1 plus pipe gap, so that's just going to be the same. That's the Y location for where the image is getting placed. Alright, so that's fantastic. If I have a collision, okay, through the bottom, and I can sail through the middle. Fantastic. Right, so if I collide, then rather than just having the hit sound happen, I need to lose a life. So let's have a variable here called lives, and give myself 5 to start with. And I will move the pipes out of the way. I'll reset them again. So let's this is the code that resets my pipes. When it moves off the left edge of the screen, I can use the same code to reset them in the case of a collision. So I'm going to copy those 3 lines and I'm going to paste them down here like that. And I might as well, let's see, what else do I need to do? So I need to deduct one of my lives. So lives minus 1, minus equals 1. And then, so let's see how many lives I've got left. So if my lives has become less than 0, the game's going to be over. And so what's my variable for that called again? Game running, right? So let's set game running to false, and instead of hit we'll play the die sound, and then we'll turn this into an else statement and put the hit.play inside there. So if we haven't run out of lives, we'll just play the hit sound effect, and if we have run out of lives, we'll play the death sound effect and stop the game from running. And we reset our pipes, and I think we're almost done. So if I come back here, okay, all right, so I'm not getting that continually There we go. And I died, and it reset me back to the start. Okay, now you notice it reset me straight back to the start again after that first. It's not giving me the 5 lives anymore. So what's actually happened is I have not reset my lives variable. So I need to, when I start a new game, let's put lives back to 5. And I want to display how many lives I've got. So let's put in here text lives and display it at maybe the top left corner of the screen. So about come in, remember we've been centered, we need to give it the center location of where we want the text to appear. So 10 pixels in on the left and maybe 20 pixels down from the top. Let's see if that's going to display how many lives we've got. There you go, nice number 5 there. 4. Can I get through one of them? There we go. and now let's just die. Okay. Now I just need a points system. So let's figure out what score I can get. Let points equal 0. And when do I want to gain a new point? Whenever the pipe makes it past the left-hand edge, we can increase our points. Plus equals 1. And we'll display that on screen as well. Text points. And let's put that on the right-hand edge. So game size, the width, and we'll come in maybe 20 pixels because we want it to have room to be double digits, and 10 pixels down from the top. So the last thing we want to do is, when we reset our game, also set the points back to 0. If I save and run this, I think we're about done. So there's my points total. Let's see if I can actually get some points. There we go. Hey, 1 point. 2 points. Oh, just sailed through that one. Alright, that's Flappy Bird. And now you just need to upload it to a web server. So the last thing you need to sort out is hosting your website so you can access it from your phone. The easiest way to do this is I'm going to get you to use GitHub. So if you don't already have a GitHub account, sign up to github.com, and rather than using the Git system, we'll just do it manually through their web page. So if you go to repositories and click on new, and I'm just going to create one here called demo Flappy Bird, and you want it public so that you can access it through the web servers later on, and click create repository. This will basically create a project area for you on GitHub. So now you've got your user account /demo, and so there's nothing here right now, and so there's a couple of different ways we can do this. And you can see here we can upload existing file. So if I click on that, drag files to add them to your repository. So if I get my Windows file folder browser, select the contents of that folder. I don't need the zip file that I gave you before because we've already extracted that, but I need my media folder, my CSS, HTML, and the JavaScript files. Click and drag all of them into here, and they will all upload to GitHub. Right, and then once that's finished, click commit changes. And you see here I now have all my files here on my GitHub page. The final step is to go to settings and scroll down from the options tab, scroll down to GitHub pages, and you want to turn this on. So source, select main, and click save. And what this will do is turn your GitHub repository into a website address, and it says your site is ready to be published at here. So now if I just open this into a new tab, there's my Flappy Bird game. And so now I've got an address that I can use on a phone to play with the game. All right, have fun with that. This is Mr. Baumgarten signing out.